Hello, and today's learning target is I can graph in any form. So we will start with reviewing graphing in slope-intercept form, then we will look at point slope and standard form to graph. So let's take a look here at our first couple examples. So within slope-intercept form, remember to start with the y-intercept and then move according to the slope. So with line A, we have y equals 2x plus 5. So I'm going to make this one blue. And so I'll go up 5 for my y-intercept and graph that point first, right there, and I'm going to move according to my slope. So my slope is 2x, or 2. The 2 is in front of x, so that's m, our slope. So I'm going to go up 2 units over 1. And again, this is a positive 2, so it should be going in an upward trend from left to right. Or I could do the opposite and go down 2 units to the left 1. And again, that will give the straight line. So I'll connect those. And remember, it's good to make your line go through the entire graph. Have arrows on the end of your line. Okay, let's look at line B. So again, I'll first graph the y-intercept, which here would be -3. And then I'll move according to the slope, which is 1/4. So I'll go up 1 unit over 4. Up 1 unit, 1, 2, 3, 4. And again, that's the same thing as down 1 unit to the left 4. Whoops, there we go. And then, again, it's always good to at least make 3 points if you can, or more. And again, make sure your line goes through the entire coordinate plane, and then arrows on the end of your line. All right, last line here, line C. Here, there is no y-intercept, right? It's plus 0. So I'll graph 0 and then move according to the slope. So up 3 units over 1, up 3 units over 1, or again, I could reverse that and go down 3 units to the left 1 and get my line there as well. Now, in each of these, I didn't mention, M. I didn't write down M and what B were. I probably should have. That would have been easier. But again, as long as we identify those important features from the line and are able to graph them, then we're going to be just fine. But it's always good to write them down so you know exactly what you got to graph first, again with the y-intercept, and then move according to the slope. So here was a review of graphing in slope-intercept form. And again, we graphed the y-intercept first and then moved according to your slope. Now let's review graphing from point-slope form. We will first take out the point and slope from the equation. Then we'll start with the point on the graph and then move according to the slope. So again, just to remind yourself, point-slope form is y minus y1 equals m times the quantity x minus x1, where y1 and x1 are the the two values that make our ordered pair or make our point that we're going to take out, and m represents the slope. All right, so let's look here at line A. So I'm going to zoom in. And again, if you recall, the important feature that we have to remember with point-slope form and taking out the point is that we really change the sign. So here, let's look at line A. So again, we're going to look at this term here for our x-coordinate and this term here for our y-coordinate. And so what I'll do is I will take out the point. Again, it's the opposite sign. So this would be 4 and then a positive 1. And again, the reason that they're the opposite sign is because in the actual equation of point-slope form, we start with subtraction signs, right there and there. So in order to put in a point and get here a negative, x minus 4 or y minus 1, we had to have put in a positive value for it to stay negative. So again, it's the opposite sign. So that's my point. M is 2 over 1. And so I'll graph the point for 1, and then I'll move according to the slope, which would be 2. So up 2 units over 1, or down 2 units to the left 1. Okay, make my line as straight as possible. Go through my entire coordinate plane with arrows on the end of my line. And that would be line A. Now let's look at line B. Again, I'm going to look at this number and this number to take out the point. And again, I'm going to switch the signs. So I'm going to get -2, +5, and my slope is -3, or -3 over 1. So go ahead and graph this point, -2 up 5, and then I'm going to move according to the slope, which would be down 3 units, and then to the right 1. Down 3 units, to the right 1. Or I could go up 3 units to the left 1, and then I'll make my line as straight as possible, going through all those points, and that would be line B. Okay, let's look at line C. So I'm going to use this number again and this number to take out the point. Again, I'll switch the signs and get -6, -4, and then my slope, really, this negative sign has it's a -1, right? You don't need to write, though, the 1 if there's a slope of 1. So my slope is -1. So I'm going to graph the point -6, -4, and that will be right there. And then I'll move according to the slope. So I could go down 1 to the right 1, or up 1 to the left 1. Get a few points plotted. And then there's my line. So again, just to recap, graphing in point slope form means we have to first take out the point that we can see from that's on that line from the equation, and the slope, and then we will graph the point and then move according to the slope. All right, and finally, let's look at graphing from standard form. So we can graph standard form in 2 ways. We could either find the x and y intercepts, which we'll talk about, or plot those points and graph the line between them, or we can rearrange the equation into slope-intercept form. So we'll look at a couple different ways of graphing standard form. So line A says x minus 2y equals 18. Let's practice for this example by rewriting this into slope-intercept form. And then we know how to easily graph in slope-intercept form. So this says x minus 2y equals 18. So I want to solve for y. So and we've practiced this before, rewriting between forms. So I'll go ahead and subtract x and get -2y equals -x plus 18. And then to get y by itself, I'll divide everything by a -2. So I end up getting y equals -1 divided by -2 is positive 1/2 x, and then 18 divided by -2 is -9. Make that look easier to read. So this would turn into y equals 1/2 x minus 9. So if I graph that line, again, I would go graph the y-intercept first, which would be -9, and then move according to my slope. So up 1 unit over 2, up 1 unit over 2, or I could go down 1 unit to the left 2, get a couple points plotted, and make my line. Okay, let's look at line B. And for line B, I am going to find the x and y intercepts here. So the x and y intercepts are points where the graph crosses the x-axis and the y-axis. So the x-intercept, again, is when your line crosses the x-axis, right, which would be the, and I'll zoom out here, which would be this part, right, the x-axis. And the y-intercept is where your line crosses the y-axis, and we already know that because of slope-intercept form when we discussed, y-intercept, y equals mx plus b, graph the y-intercept first, move according to the slope. So x-intercept is no different. It's just where your line crosses the x-axis. So in order to find your x-intercept or y-intercept, all you need to do is plug in 0 for the opposite variable and solve. So think about it. When you want to find the x-intercept, y is 0, right? Because that's where it crosses that axis, that flat axis. And then the y-intercept is where x is 0, where you cross that vertical line, right? So you don't move over on the x-axis anything, you just go up or down on the y-axis. So you're just setting 0 in for the opposite variable and solving. So if I find the let's find the x-intercept first. So I have 3x plus 3 times 0. Again, all I'm doing is plugging in 0 for the opposite variable, and I'm solving for the variable I want to find. So let's rewrite that so it looks better. 3x plus 3 times 0 equals negative 6. Well, 0 times anything is 0, so 3x equals negative 6. Divide by 3, x equals negative 2. So I will go on the x-axis, and I will plot negative 2, which would be right there. Right, when y is 0, x is negative 2. Now I'll solve for the y-intercept. So I'll say 3 times 0 plus 3y equals negative 6. 0 times anything is 0. So 3y equals negative 6. And here I get y equals negative 2. So I end up getting the same value, but now when I graph that, that's on the y-axis, right? So I go down 2, that's the y-intercept. So x is 0, y is negative 2. And you really only need 2 points to make a line. So let's connect those two points and make our line. So it'll look something like this. So again, we could graph that a line by using the x and y intercepts, or like line A, rewriting to slope-intercept form. All right, and let's look at this last example here, line C, and let's practice rewriting to slope-intercept form again. So let's solve for y. So I'll subtract 4x and get y equals negative 4x plus 3. And look, after that one move, we already have it to slope-intercept form, so that was very simple. So let's graph this equation. So I'll go ahead and plot my y-intercept at 3, and then I'll move according to the slope. So down 4, over to the right 1, down 4, to the right 1. Or again, I could go up 4 units to the left 1. Connect that, or those points, and get my straight line. And again, this was graphing in standard form, where, like examples for lines A and C, we rewrote to slope-intercept form, or like line B, we solve for the x and y intercepts when beginning in standard form. So a couple different options you can use to graph, and we can practice both different types to get some practice. Thanks for listening to the video on graphing in any form. Again, we graphed in slope-intercept, point-slope form, and standard form for linear equations. Have a great day. Bye-bye.